What does AMD have for AI? Executive summary: AMD is expanding aggressively into AI with its EPYC-CPUs, Instinct Accelerators, and XDNANPUs. EPYC chips emphasize energy efficiency, while Instinct GPUs like the MI300 and MI350 target large-scale training and inference with high memory bandwidth and scalable interconnects. AMD also pursues rack-scale systems for data centers, highlighting power savings and open software through ROCm. Compared to NVIDIA, AMD often offers lower upfront costs and efficiency benefits, but struggles against NVIDIA's stronger ecosystem, optimized software, and performance leadership. To compete, AMD must prove scalability and reliability in real-world deployments while continuing to close the performance and adoption gap. Article: in the rapidly evolving arena of artificial intelligence, hardware providers are racing to deliver chips that combine high compute throughput, memory bandwidth, and efficiency. AMD, a long-standing competitor to NVIDIA and Intel in CPUs and GPUs, is pushing aggressively into the AI accelerator and data center space. This essay surveys what AMD offers today and in the near future for AI workloads, especially in high-end CPUs and accelerators, what its strategy is for large-scale data centers, and how its offerings compare to NVIDIA in terms of price, performance, and total cost. What AMD offers: CPUs, GPUs, and NPUs, high-end CPUs, and AI integration. On the CPU side, AMD has long been strong with its EPYC server processors, and it is leveraging that strength as AI workloads increasingly require tight integration between general-purpose compute and AI inference/training. According to AMD, its EPYC line offers favorable energy efficiency. The company claims EPYC outperforms NVIDIA Grace CPU superchip by up to 2.75 times in power efficiency for AI and business applications. This energy advantage is significant because power is a major operational cost in data centers. AMD is also working to integrate neural processing units (NPUs) more broadly. Its XDNA architecture is a microarchitecture for NPUs, derived partly from its acquisition of Xilinx, designed to accelerate on-device AI and machine learning workloads. In consumer and edge devices, AMD is putting XDNA into its Ryzen AI branding, combining CPU cores, RDNA graphics, and the NPU together. While these NPUs currently target edge, client, and on-device AI use cases, the direction suggests AMD is thinking about heterogeneous integration across compute types. Accelerators, the AMD Instinct line. The heart of AMD's AI data center push is its Instinct Accelerator line, built on the CDNA architecture, CDNA, CDNA2, CDNA3, and now CDNA4. These are data center GPUs, or GPU-like accelerators, tailored toward deep learning training, high-performance computing, HPC, and AI inference, analogous in many ways to NVIDIA's Tesla/A, 100/H, 100/H, 200/Blackwell line. Some notable offerings and characteristics: the MI300 series, MI300EOA, MI300X, are among AMD's current flagship accelerators. The MI300A is an APU design that combines CPU cores and GPU cores with high-bandwidth memory (HBM), while the MI300X is more of a pure accelerator. AMD recently announced accelerators in the MI350X/MI355X series, built on CDNA4, which use advanced chiplet design and support very large memory HBM3E to serve demanding AI workloads. The Instinct line supports a broad range of numeric precisions useful for AI, from FP64 for scientific compute, down to FP16, INT8, and emerging formats like FP4/FP6, especially for inference and sparsity. AMD promotes the scalability of its Instinct accelerators from single-server solutions up to exascale-class supercomputers. On the software/stack side, AMD leverages ROCm, Radeon Open Compute, and open standards to support AI frameworks, and to differentiate itself from more closed ecosystems. In addition to its data center GPUs, AMD also leverages its Radeon line, especially the RX 9000 series, with AI acceleration capabilities, targeted more toward content creation, gaming, and development, rather than large-scale training. The RDNA 4 architecture includes second-generation AI accelerators, supporting FP16, INT8, and sparsity for workloads such as AI upscaling, inference, and machine-learned effects. Overall, AMD offers a heterogeneous stack: general-purpose CPUs, ePYC, AI-capable GPUs, accelerators, Instinct, and NPU-S XDNA in more client-edge settings. AMD 6. AMD's strategy for large data centers. Deploying AI at scale requires more than just fast chips. Infrastructure, networking, cooling, system integration, and orchestration also matter. AMD is positioning itself to provide full-stack support for AI and data centers. 1. Rack-scale systems and full-rack solutions. AMD is promoting not just individual accelerators, but complete AI rack systems that can be deployed at data center scale. For example, AMD has touted full-rack AI data center systems and claims advantages over NVIDIA in those integrated solutions. Looking ahead, AMD is reportedly preparing rack-scale Instinct systems, MI450X, IF64, and IF128, that will integrate dozens to over 100 GPU modules into a single system using its Infinity Fabric and Ethernet-based interconnects. These will compete with NVIDIA's VR200/NVL systems. 2. Scalability and interconnects. The chiplet design, Infinity Fabric interconnect, and advanced packaging allow AMD's accelerators to scale, ideally, with low latency paths between chiplets. For rack scale, AMD plans to link multiple GPUs via Infinity Fabric over passive cabling, aiming for high internal bandwidth. 3. Energy efficiency and TCO focus. Because cost of energy, cooling, and total cost of ownership, TCO, dominates when operating large AI clusters, AMD emphasizes efficiency. Its claim about ePYC outperforming NVIDIA's Grace CPU in power efficiency is one example. Also, benchmarks and analyses suggest that AMD's inference servers may deliver better performance per dollar TCO in some scenarios. 4. Software openness and portability. AMD's positioning as a vendor that supports open standards, open source stacks, and heterogeneous computing is a strategic advantage for customers who want flexibility. If companies want to avoid lock-in to a single vendor stack, e.g. NVIDIA/CUDA, AMD's more open approach may appeal. 5. Cautious market pacing. Some analysts observe that AMD expects the AI accelerator market not to boom indefinitely in 2025, possibly due to customers deferring large investments until next-generation devices arrive. This may reflect a real strategy of stepping carefully into large AI deployments while improving the roadmap for future generations. Price/performance and competitive comparison to NVIDIA. When comparing AMD and NVIDIA in the AI space, the debate often comes down to price performance, or TCO, software ecosystem CHA compatibility, and scalability/feature advantages, price and upfront costs. AMD often pitches its hardware as cheaper at the outset. Some sources suggest that AMD's MI300X is 10 to 20% cheaper in list price than NVIDIA's equivalent H100 or comparable model GPU. For many customers, a lower upfront price is attractive. AMD also touts energy efficiency gains, which reduce electricity and cooling costs over time. However, a lower sticker price doesn't always guarantee lower total cost for delivered AI work, utilization, ecosystem, and realized performance. One of NVIDIA's strongest advantages is its mature ecosystem, CUDA, QDNN, and broad software support, which allows many AI models and frameworks to be highly optimized for NVIDIA hardware. Many users can push NVIDIA GPUs to high utilization, squeezing more work per dollar invested. In practice, that means that even if AMD hardware is cheaper per unit, NVIDIA may extract more real work from its hardware, leading to a lower effective cost per AI task. Some analyses argue that NVIDIA's ROI advantage, that is, better utilization per GPU, means that true TCO might favor NVIDIA in many real-world scenarios. A semi-analysis benchmarking article looked at inference performance and cost, concluding that the results are nuanced and surprising, not clearly favoring one over the other. Performance gaps and market position. While AMD is improving rapidly, NVIDIA still leads in many benchmarks and in broad market adoption. NVIDIA is often viewed as having a performance advantage, especially for newer models, and deeper software optimizations. Some analysts have even downgraded AMD stock, citing concerns that NVIDIA's performance edge will widen. In terms of market share, NVIDIA dominates the AI accelerator market. Some sources put it at approximately 80% share, largely due to its entrenched software and ecosystem. So far, AMD is making progress in closing the gap. Its MI300/MI350 series are competitive on paper for throughput and memory, especially when considering sparsity support and mixed precision formats. But actual deployment-level benchmarks, scaling behavior, and software optimizations still tend to favor NVIDIA. Conclusion. In summary, AMD today offers a compelling and growing portfolio for AI, high-performance EPYC CPUs, AI-aware NPUs via XDNA, and a robust lineup of data center accelerators in the Instinct series. Its strategy for large-scale data centers is ambitious: rack-level systems, high-speed interconnects, and emphasis on energy efficiency and openness. However, in the head-to-head comparison with NVIDIA, AMD still faces serious challenges. NVIDIA's deep ecosystem, mature software stack, and real-world performance optimizations provide it with a lead in many deployment scenarios. While AMD's lower cost and power efficiency claims may tilt total cost advantages in favorable cases, many users will remain cautious until AMD proves itself at scale in production AI systems. Over the next few years, AMD's success will depend on its ability to push down the performance gap, deliver efficient and scalable infrastructure, and build developer trust in its software and optimization stack. If it succeeds, AMD could become a meaningful alternative, or even competitor, to NVIDIA in the AI compute market.